Hi, this is Albert Yip. This is the first of a series of lectures on a big history. I'm delivering this big history course to U3A and specifically at U3A Nana Wedding in Melbourne here. The course will run during the school terms in Melbourne here, except when I'm trying to have a holiday. Okay, most of the times I will be giving this lecture once a week, and it is on Tuesday. So this is the first of the series of on big history. I was trying to do this as a video capture of the lecture itself. Unfortunately, the quality isn't good enough, so I am now going to just talk through this instead of using the live videos. In case when there are discussions arising from the class, because I do have the videos, then I will take in some of the comments from the class members and then put up here as well. So what is big history? Big history is really big. It's about the whole of history, from the beginning of the universe to present. So this is big. Big history started by this man, David Christian, back in 1989. So it's over almost 40 years ago now. He was interested, or actually, he was asked to deliver a history course to non-history major or minor students at University of Macquarie in Sydney here. So he was wondering if I'm going to deliver a course to non-history students, where should I start? Should we start by looking at the first group of Europeans arising here, so-called the first fleets? Or should we also talk about the history of the Aborigines here in Australia? What about further back into the beginning of written history, or even further back? He was pondering these questions when he met some of his colleagues, probably in one of those cafeteria where he's having lunch or break, wherever. Some scientists suggest to him, why don't you start from the very beginning? What do you mean by very beginning? Well, the very beginning means the beginning of the universe, of everything. Well, that's a good idea. But as a historian, how can he do that? How can he cover cosmology, geology, biology, or any other science subjects which covered in this particular course? So he get helps from his colleagues. There he come. Then we have big history. Why I'm interested? Well, curiosity is a sufficient reason by itself, I suppose. But I'm also a humanist. Okay, I'm quite concerned about whether we can leave a better world to our children or grandchildren. We inherited a world from our parents. So what are we going to give our children or grandchildren? What kind of world we are going to give them? I have been thinking about that for a lot of time, for quite some time, especially in terms of global warming and all the other things that's happening around the world. In particular, at the moment, the United States of America represent about 4% of the world population, but it uses about 20 to 25% of the world's resources. So if one day, just one day, when China catch up with the kind of use of resources like the Americans, China has about 20% of the world's population. about 4 to 5 times larger than than America, then the whole world's resources will be used just by China and probably by United States. What's left for the rest of the world? That's not sustainable. That can't last. So I start thinking about all this. And unless our generation, this generation, can provide some kind of solution, the world we are going to give to our children or grandchildren will be worse than what we get from our parents. That's one of my concerns. The other interesting thing about this subject is its nature of almost embracing everything. It is a very big subject. I think most people should have a little bit of understanding of how we come about, what the world was like, and how we get to this day, and what we are looking forward to, etc., etc. These are fundamental knowledge that every man or every ladies should have. So that's why I'm interested in this one. Want to learn, and hopefully, with this, I can have some insight into what our future will be and what can we do to shape the future. Big history, of course, talk with big trends from the beginning of the universe to today. So we can try to draw some common themes, look beyond today and into the future. But this course is unlike any other history course. This course is evidence and science based. It's based on a scientific understanding of the natural world. It's based on evidence. As science develops, we need to update the material for sure, but we'll see. So talking about that, what is a scientific theory? According to Wikipedia, a scientific theory is an explanation of an aspect of the natural world that can be repeatedly tested and verified in accordance with the scientific method using accepted protocols of observation, measurement, and evaluation of results. So basically what we are saying is that what science is about things that has been tested over again. That means things that are true in the sense that it can be tested and it can be verified. That means whatever science describes is something that you or I or anybody else can repeat and get the same results. So in this particular case, miracles is not a scientific theory. Miracles, if they do happen, is a one-off event. It is not repeatable and it cannot be verified. You may argue that there are people seeing that or witness of that kind of event, but we have to rely on their words rather than relies on we can check it. We cannot check it ourselves. So miracles in particular is not a scientific theory. And so in this course, we will not talk about miracles except by understanding the impact of miracles. But we will not accept the claims in the miracles. If the miracle claims something, for example, Virgin Mary, okay, it claims Mary was virgin when Jesus was born. Well, it can make the claims, but I can't verify it. I have no verifiable evidence, so I will not accept it as part of the argument in this course. This course is based on repeatable, verifiable facts. Now, this use of the term theory is quite different from the everyday use of the theory. In everyday speech, theory can be implied an explanation that represents an unsubstantiated and speculative guess, whereas in science, it describes an explanation that has been tested and widely accepted as a valid. So that's quite different. It's not, when I say a theory is a theory, well, a scientific theory is not a theory in the common use of the word. Some of the characteristics of any scientific theory is that it is falsifiable. That means I can design an experiment to prove that it is wrong. Well, if the result come out is wrong, that means I cannot prove it. Then the theory still stands. But once I find a counterexample, then the theory is falsified. So all scientific theories can be falsified. Of course, it will limit to the domain it applies. And scientific theory is also supported by many independent strands of evidence. So it's not a single foundation kind of thing. It's supported by almost everything. And it is consistent with all existing experimental results, and is able to predict as accurately as any pre-existing theories. So let's break it down into smaller elements and look at it. So first of all is, what is a scientific fact? A scientific fact is a repeatable careful observation or measurement. So that's called the empirical evidence. So it is a single observation. For example, I have a rock, I let it go, and then it fall down. So that's one observation. And this observation can be repeated by anyone at any time, at any place, or except when the theory is specific about a place. Otherwise, it should be repeatable by anybody at any time, at any place. So that's called verifiable. That means you or I or anybody else can make the same observation under the same condition. A little bit above the scientific facts are scientific laws. Scientific laws is a statement which collects all the scientific facts into a single statement. That means this statement becomes much more general than just one empirical fact. For example, when we say the Newton's law of gravity, so that is a law, and that law describes all kinds of relationship between different mass. For example, we have a stone, which is a mass, earth, another mass, and then if I let go, then the stone will fall towards the earth, or the earth fall towards the stone. But anyway, they will come together. There's an attraction force there. The same attraction force is also apparent, is also applicable, for example, between the sun and earth. So this is the same. Then when we combine them together into the Newton's law of gravity, that explain a number of facts about gravity. So scientific laws are actually is a summation of many results of many experiments, usually applied to a certain range. So they are the distillations of results of repeated observations. Law and theories are a little bit different. Theory is a bit larger. It might include several laws, and then all of them combined together to provide a broader scope to explain something. The words explain here also need a little bit of explanation, I suppose. When we say a theory explains something, that means the theory provides a logical argument which will come to the conclusion of your observation. So using the theory, you can see the relationship between something and something. They are related, and the relationship is described by a scientific theory. Of course, all scientific theory depends on how you produce the theory, so that's called the scientific method. The scientific method is an empirical method of acquiring knowledge. Is usually considered to start in the 17th century. What does it mean? It means careful observation, apply rigorous criticism, skepticism about what is observed. That means we see something, we try to look at it from different angles, try to work out whether that what you observe is actually there. So you will have very rigorous skepticism about what you are looking at. So we know that our cognitive assumption can distort our interpretations. That is exactly what we try to avoid. We try to avoid our personal subjective observations or assumptions in order to make the observation. When a number of observations are made, we want to produce a hypothesis, basically the beginning of a scientific law. That law will try to provide explanations about all the facts you have collected. So this hypothesis should be able to explain the facts. Obviously, once you have a law, then everybody is trying to disprove the law by trying to find a counter example. So if no counter example can be found, that means the hypothesis can sustain quite a lot of criticism. Then it may progress to become a scientific law. Obviously, sometimes the hypothesis need to be refined, make modifications, or even rejected. For example, you find a counter example. That means your hypothesis is wrong and therefore it is completely rejected. The hypothesis will become a scientific law or theory when there's no known false prediction. That means whatever we observe using this theory comes out to be correct as predicted, then it is considered a scientific law. It describes all known scientific facts under the same which the hypothesis apply. So this is a very brief summary of what is scientific theories, scientific facts are about. As I have said, this course is based on science, so we will be looking at a lot of these theories as well as facts. I understand that some of the theories and facts is not my domain of knowledge. It may not be your domain of knowledge as well, and therefore we will come into some difficult parts which I may be struggling to explain because it's not my field, but I will try my best. At the same time, you come up with anything that you find you can't understand. Welcome to leave a comment in the comment section. I will look at the comments as regularly as I can, and then probably reply to you or make a extension videos to explain what is not has which haven't been explained very well. Thank you for coming along and hope to see you next week. Bye.